Welcome to the Ad Dot Podcast, everyone. I have a guest with me today, John Demick. And John is currently co-founder and CTO of a company called HyperCurrent. And John has a very strong background in APIs and middleware and so forth. And I met John, I don't know, maybe 8-10 years ago or something. I know that we had some correspondence, but anyway, let's get to know John better together and his experience and see what we can learn from it. So welcome to the podcast, John.
Sounds good. Great to be here, Vaughn.
So I think when I first maybe had some kind of contact with you, I mentioned in my Implementing Domain-Driven Design Red book, Mulesoft, right? There was like a little story in the architecture chapter, still there, obviously, about this company, fictitious company, SAS Ovation, and one of the tools that they were using was Mulesoft ESB. And I think sometime after that, maybe you introduced yourself by email, and I think we exchanged some pleasantries, and then I think a few years after that we met. I had a workshop in New York, and you attended that in New York City. So anyway, tell us about, let's go back to Mulesoft with the ESB. Tell us about ESBs for those who aren't real familiar with what those are.
Yeah, no problem, Vaughn. So ESBs they started as an architectural pattern. I want to say they were actually documented in the Enterprise Integration Patterns book that came out in the mid-2000s. As a tangent, that book is excellent, and most of it is still very applicable today. But after that book was published, a bunch of commercial and open source sort of projects fell out of it that implemented an ESB pattern. So an ESB, again, is an enterprise service bus. The idea with it back in the mid-2000s was for, at the time, to take SOAP APIs, which was the dominant API integration implementation, and essentially connect them to a bus where the bus would be a central point for non-functional business requirements for these APIs. So the bus would handle things like mediation, routing, security, authentication, reliable delivery, right? All the stuff that we take for granted now with things like messaging brokers were all sort of centralized in monolithic enterprise service bus pattern.
Right. And at the time, as I recall, messaging was like JMS, Java messaging service. And so it was, it had most of the kind of broker type features in the API, but you also needed an implementation behind that. Pretty sure that, most of the J2EE app servers at the time had JMS support, and then came along message-driven beans, which I thought were horrendous. I don't know how everybody else felt about those, but so how did you build a message broker underneath the enterprise service bus, or how did that work?
Yeah, so at the time I was chief architect at a startup called OpSource. So at OpSource, we had actually successfully implemented a ESB internally. Granted, we were a startup and our footprint was modest compared to a large retail bank or something. But for our particular implementation, this is actually how I got involved in the Mule project. Is we were using a nascent version of Mule. I want to say it was like a pre 1.0 version, using that as a central broker for our different SOAP-based web services. And then underneath the Mule implementation, we had a variety of different message brokers that we had experimented with. I think we landed on, at the time, it was called OpenMQ, something that Sun had open sourced. But before that, I had tried ActiveMQ and a few other things. But essentially, the pattern was that our SOAP endpoints were effectively dumb. So they would send traffic back and forth to the bus. The bus would go and then transparently persist the XML messages onto the messaging layer, which would give us reliable delivery and routing. And then we'd use that to pass messages around the different services in our organization. and then also do transformation, et cetera.
Yeah, which is go ahead. Sorry.
Yeah, I was going to say quickly too, and this sort of explains how the Mule project itself evolved. Is that we also use the bus as a decoupling point for our external integrations. So I want to say we were doing work with a ticketing system. I want to say it was Right Now. Maybe this would have been like in 2006, 2005. But essentially we had these SaaS services that we were using, and then we would use the bus as essentially a anti-corruption layer for our external partner integrations as well.
Yeah. Interesting. Yeah, that takes us way back. And around that time, maybe anti-corruption layer pattern was barely known by, through Eric Evans' book. So what kind of happened with ESB? I mean, from my perspective, I think people started using the bus for business logic. They would deploy some things there in a rush to get some things done, and that's one perspective. But what did you find?
Yeah, I mean, I think there were two sort of backlashes against it that were valid. One technical and one maybe political. One of the technical patterns that came along with ESBs were canonical data models. So the other kind of pattern is that as different disparate services were landing messages on the bus, you transform to a canonical format that the bus would use internally, and then from a corruption layer standpoint, translate back and forth from the different services. These canonical formats, however, were complicated, and in general, within an organization, if there's different domains, trying to get everyone to agree on a single canonical model for everything that's cross-domain or cross-context. That generally falls over. I'd say the other pitfall that bit the ESB patterns and vendors in general was also they were complicated, and that generally meant a centralized team would manage the bus, and usually that would be some function in central IT. And then as different services were getting onboarded on the bus, it required more and more work from the central team that essentially were if they generally weren't well funded in some places. And then just became bottlenecks in terms of getting services and data in and out of the bus. And this led to just different organizations doing their own thing in silos, sort of defeating the purpose of the whole pattern altogether.
Yeah. But I think you got one thing right. It seemed like you got, dumb pipes, smart endpoints? I mean, that was what it was supposed to be, right?
Yeah, exactly. Yeah. Right.
So, but there were plenty that were doing, sort of smart pipes in a way. But so then, okay, so ESB kind of got, went from fast track to off the track, I guess. And Mulesoft, I don't know, did you see that coming at Mulesoft? And either way, how did you react to that?
Yeah, it was interesting. So my journey with Mulesoft and then the framework in general was realizing that the value that it gave was ironically not much. Shouldn't say not much. It wasn't primarily in the ESB world. It was more as in the integration and transformation pieces. So where I got really successful using Mule was using it within, at the time, Java and Spring apps embedded, and then using it to transform data back and forth from different systems. And then the way that at least I thought about it was like a distributed ESB that was embedded in each of the endpoints versus a monolithic thing that was deployed centrally and doing centralized routing and transformation. So when I joined Mulesoft in 2011, that was sort of the hypothesis I came in that company, thinking that as ESBs were going away, there was still a lot of value in this framework as an embedded transformation and integration layer and framework. So would you say that because kind of the routing knowledge was, I guess, at the service level or in services, was that sort of more like a choreography, whereas the ESB was more like an orchestration? Yeah, the way that we started thinking about it, and this is at least from my perspective, how a lot of the API-led and API-first thinking sort of came out of Mulesoft. Was essentially thinking about APIs and then eventually microservices as falling into two different camps. So one sort of API or microservice could be very business or domain centric. So those sorts of things you'd build in a traditional language like Java or .NET, and then use frameworks like Spring. And then those again would be heavy on domain modeling and objects and traditional sort of software development. But then, particularly in large enterprises with a lot of legacy investments, you'd have microservices that were very transformation, orchestration, and potentially choreography focused. Right. So these are things that are integrating with mainframes, integrating with legacy databases, potentially not having any real business logic in them. So essentially just, querying databases and transforming the result sets into different formats, JSON, XML. And then, so these sorts of services didn't really make a lot of sense to write in a traditional framework. And that's where I think Mulesoft really took off, is when we made that distinction.
So how would you describe that it was done with the, when Mulesoft really took off? What was the difference in the way the services or the endpoints were implemented?
Well, I think that the main difference was a push to do API-led or API-first implementations. As much as that term has been, overloaded and abused, unfortunately, but it was this idea that as organizations were building out services, to think of them as being composed, and then thinking about them from the API contract first, and then implementing downstream from there. And then what's interesting about that approach as well is that that's also agnostic of the technology, right? Because the APIs, if they're designed properly, should hide the backend implementation. So this allowed a technology team to pick the right tool for the job in terms of how to build out the backend. And in a lot of cases, that happened to be Mulesoft, because again, most of these things were very transformation and orchestration focused in more traditional enterprises.
Yeah. So, and you went from SOAP, sounds like in the ESB, or maybe mainly SOAP, but probably also you switched from there probably to REST, is my guess.
Well, yeah, that was the other evolution from the mid 2000s to the present, right? So there was also a very large backlash, and this with heavyweight SOAP and XML frameworks. The major problem with SOAP, beyond the actual frameworks being brittle, was that they were very dependent on automatic contract generation from programmatic schemas. So the general pattern is that you take like a Java or a .NET interface class and then push a button, and then we get some massive WSDL that was almost impossible to actually parse yourself, right? And then you use this as the contract for interchange. But then, since these things were so complicated, and the corresponding XML schemas, the XXDs, were also extremely complicated, unless you were using the same SOAP stack on each side, there was all sorts of interoperability issues in between the SOAP stacks, which defeated the purpose of using intermediary exchange protocol. Where I started to get successful with SOAP, ironically, is when I started writing the WSDLs by hand. So rather than use the programmatic approach, I would author I'd start with the WSDL, write my XML schemas, and then generate the service interfaces the other way, so backwards. And that's actually where we started to get successful at OpSource with XML SOAP-based interfaces. As this evolved, there was kind of a bridge between SOAP and now the RESTful world with things like OAS, Swagger, and RAML, where people were using formats like JSON, right? So it was basically JSON or XML over HTTP. That worked well, but there was no real schema to it. So it was sort of ad hoc in terms of how you integrated with these intermediary RESTful formats before the formalized contract languages came. And then again, like in the 2013-ish timeframe, Mulesoft then introduced RAML. There was Swagger, and that's when I think you saw REST APIs explode from a popularity standpoint, because you had the ease of integration coupled with the tightly defined schemas to make integration easy.
Although, yes, good. And I would say, though, that some people might conclude that even Swagger or OpenAPI specification is not the easiest thing either, even compared to, WSDL definitions. What do you think of that?
I agree. And there, I'd argue that RAML and Swagger are overly verbose. We've actually, at HyperCurrent now, have come up with a good middle ground in between the two. So we're using Kotlin as our implementation language. And we actually start with designing our controller layers and our views first. And the views are data classes in Kotlin. So, very easy to parse. Like when I say parse, I mean, you can visually look at the data class and see what the fields are and the data types. And then we're producing the OAS contracts off of that interface. So that gives us the best of both worlds, where we can, define like a really concise contract, and then view or DTO in Kotlin produce the OAS documentation off of that automatically, and then have our domain logic decoupled from that intermediary layer.
Yeah.
I'm still struggling to come up with a name for that pattern, but that's what we've been using. It's been pretty successful so far.
Yeah. Actually, Olaf Zimmerman and his co-authors just had their book published under my signature series, and it's called, Patterns for API Design. And in that book, they talk a bit about, MDSL. And MDSL is, it's actually a textual DSL, not a programming, language DSL, or not based on an existing programming language. And it actually reduces the OAS spec, overhead quite a bit. But out of that, you get the OAS. So it sounds like a similar thing, but I like the idea of essentially it's like you have configuration as code, only it can't be code, it has to be a document, right? Or an object. But it seems like that, you get to use a programming language like Kotlin to describe that, and then you get the OAS out of it.
Yeah. And then there's also the JAX-RS annotations, or, we haven't been using Spring Boot. There's Spring Boot annotations as well that handle things like the documentation in terms of like examples and stuff that's produced in the OAS spec.
Yeah, interesting. So, you left Mulesoft maybe just a bit before the Salesforce acquisition, and you started your own consulting company? Is that what it was?
Yeah, we started a consulting practice right after I left Mulesoft. We did that for a couple of years, and then some of the founding team got antsy doing professional services. We all, kind of like wearing the product hats. So we decided to take, the experience we had working with really large customers on the consulting side and solving a particular problem that we saw in that space with HyperCurrent, which is the product company that we started about a year ago.
Mm-hmm. So HyperCurrent then, or the ideas behind HyperCurrent are, I think, somewhat different than, just like pure API management. Can you tell us about that and how the ideas came about, maybe working with clients, how those gelled?
Yeah. The original genesis for HyperCurrent was to solve a specific problem we saw in large organizations in terms of internal API usage. Large enterprises usually have a central IT team that procures something like, say Mulesoft or, Apigee or Kong, and then runs that as a central IT function. And then there's different business units or groups within the organization that build APIs that are deployed within, usually essential infrastructure that central IT manages. So the particular problem we saw was the inability for a central IT group to track utilization of APIs across different groups, and then essentially charge or show back that usage to each of the groups from a financial standpoint. So that was the first iterations of the product were focused on that particular use case. Although what we found when we were just basically testing the product with early customers is that The real interest was actually doing external monetization and productization of APIs. So this essentially meant taking an internal API investment and then focusing that API outward for other businesses to consume. So as we started to explore that space, we noticed that while some vendors actually, they have monetization features, they tend to be very developer to developer focused. Whereas the organizations that we were working with were interested in productizing APIs and selling them to other businesses. And it was more of a function of almost like data transfer, with APIs being the channel for that data and the ability to meter and monetize that data across businesses. So that's where HyperCurrent has evolved and where we are today.
Which is something actually that I've wondered why there isn't more monetization of APIs, but I think it depends on the kind of business. If you're like a financial services, well, not all financial services, but maybe like a bank, you kind of need to have your API open and freely accessible. But what kinds of businesses could actually justify monetization?
Yeah, I mean, I can say in terms of the businesses that we're working with, the main verticals are, not surprisingly, financial services, but one that actually surprised me was HLS, so healthcare and life sciences. So our biggest customer is an HLS company that's selling clinical research and natural language processing models and data via their APIs on their marketplace. On the financial services side, a lot of the monetization use cases are driven by disruption from newer companies like Stripe or Plaid, who are unbundling the services that a traditional bank might offer. And then we're also seeing interest in the energy sector. So, doing things like monetizing the location of chargers for EV or for electric vehicles, use cases like that.
So, that's interesting. So maybe Stripe, how are they, what kinds of services are they providing that would compete with traditional banks?
Any kind of payment processing, right? So something that you might go to, Visa or, Bank of America or something, startups and smaller businesses are going to, vendors like Stripe because they're easier to integrate with, mostly because their APIs are so nice to work with. One of the other things that we're doing is, ignoring kind of the commercialization aspects of it, is actually treating APIs truly as products. So when I was at Mulesoft, we talked about, treating APIs like products a lot, but that was through the lens of, again, developers. So, basically when you're releasing an API, to make sure that the contract is easily consumable, that the API is reliable, right? All the stuff you'd expect. Whereas with what we're doing is, obviously we still think that's important, but we're also covering the actual productization aspects of it and allowing these businesses to sell APIs the way that a traditional SaaS company might.
So when you describe developers working on APIs versus the whole organization, being kind of like API first, as it were, where the organization's saying we need to make money off of these things called APIs, there's a big difference between a department that simply says we're developing an API and the whole organization, like corporation, corporate wide APIs, or at least some part of it. Would you say that's kind of your dividing point where your product really shines more on the corporate side?
I'd say, the corporate side, specifically with product managers. Right. So whereas as a vendor like, Mulesoft or Kong, they'll help with the building and the proxying and the management of the APIs. We help with the actual commercialization of the API itself, right? So this means integrating with developer portals to enable functionality like checkout rather, and then also provide analytics on the product management side to see who's consuming the APIs, the quality of service for the consumers. Generally when you're selling things to other businesses, there are SLAs that need to be met. So we also do tracking of producer side API SLAs. So if there's a commitment to a certain amount of uptime or like in the case of financial services API, it could be committing to a certain latency target for data. We can track those sorts of metrics and then analyze and report on them. So it's again more on the actual product operation of an API that's being commercialized.
Yeah, good, cool. And I think that what seems useful to me too is even if the organization doesn't sell access to APIs, it could still be quite useful to see how much APIs would, in essence, like virtually speaking or hypothetically speaking, how much would they be worth? And if an API is rather expensive to develop and maintain versus how much usage it's getting and how much it could, if there was a monetization of it, how much it could make, that might be an interesting way to look at, well, is this actually worth having a team, develop this, or even a product manager work on it?
Yeah, no, agreed. Right. Yeah, it's a great way to justify budget and everything else as well. So yeah, agreed.
So, well, where do you think the industry is headed next with APIs? I mean, you must be supporting API tools other than REST. I imagine you're probably doing something with GraphQL, something with gRPC, or maybe that's still on the roadmap for you.
No, we're supporting REST REST obviously. GraphQL is supported, and then for the newer API management vendors like Gravity that have gRPC support out of the box, we can also meter those sorts of transactions as well.
Yeah, cool.
So in terms of where I see the actual space going, I think there's definitely a white space now around event-driven APIs. Just given the popularity of things like Kafka, and then all the kind of streaming stuff that's out there, that seems like it's low-hanging fruit from a publicly consumable API standpoint.
Yeah, and from those, do you see like event or even just message subscriptions coming through REST, kind of like REST callback, if you will, or do you see most of those coming through like a first class messaging system, like a broker, whatever that is, maybe SQS or SNS or something like that on AWS?
Yeah, I mean, I would love to see the latter, because I'm not a huge fan of doing event-driven things over HTTP. It just it overloads the protocol too much. But I think the first cuts of it will be the former, right? So either, like to your point, callbacks or potentially WebSockets or something, where it's something over HTTP. In terms of the latter, right, in terms of like native messaging protocols, it'd be great if there was a standard that everyone adhered to for that. But the problem is that these protocols are all over the place. There's been attempts at doing some analog to Swagger on the event-driven side, but I don't think they've gotten much traction yet, unfortunately.
Would that be the Async API folks?
That's right. I was spacing on the Async API. And that may have made progress. I haven't been tracking it too closely recently, but I mean, something like that would need to be in place, pretty significantly before non-HTTP messaging gets more popular outside of the firewall.
Yeah. I haven't tracked it very carefully. It does seem like it has some good sponsors, and I now hear clients talking about it like that they would like to look into being Async API compliant. And I'm not sure how Async API would work with REST-based, sort of message feeds, if you will, or notification feeds. But I need to look into that more. But how do you think that would work? Is it sort of like, okay, you get to listen to 10,000 events for free, and then every 100,000 events costs such and such amount of money? Like,
I mean, one one monetization mechanism could be volume based, it could be throughput based, it could be the timeliness of the data, right? So again, to things like in financial services with market data, generally you're paying for latency and timeliness, for those sorts of event streams.
Well, is there anything that you think the audience would like to hear about in general, the long-term future of APIs, what where value is going to be, maybe what they should steer clear of or what they should invest more in, something like that?
Yeah, I mean, the trend that I've been seeing and was part of the genesis of HyperCurrent was organizations invested big in APIs and microservices about 6 or 7 years ago, right? Those use cases were almost purely internal, at least in my experience. But now, as these organizations have maturity with internal APIs, that they're starting to turn these things outwards. So that's the main trend that I've been seeing. And I think the vendors you're seeing that are popping up in this space, like the API security vendors specifically, so startups like No Name Security, they're specifically addressing the sort of challenges that come when you're taking something that was internal and then facing it towards the essentially entire planet to be able to consume. And then falling out of that, in addition to the productization and commercialization aspects, there's also the security and reliability aspects of running those sorts of programs.
Do you think that GraphQL is a long-term kind of solution or go-to tool for APIs, or do you see it kind of what would you say, maybe the trough of disillusionment or something, anything like that at this point? Or
yeah, I'm honestly a little bit suspicious of GraphQL. It reminds me of SOAP a lot in the sense that it's overloading HTTP, like everything goes over a post. And then it's also probably a side effect of the implementation patterns, but there seems to be a reflex to tightly couple GraphQL APIs with databases. And that just seems like a bad idea, like just giving, some unknown third party the ability to execute arbitrary queries against your database. That just makes me nervous. So I'm a little bit suspicious of GraphQL at this point, but we'll see how that evolves.
Yeah, as well it should. Yeah, it seems like something that might work better purely internally than externally. But I think one thing that I heard maybe even a few years ago now is that GraphQL made just like a perfect CQRS type pattern, especially for the read model or the query model. And I don't know, do you run across that at all?
We're not doing CQRS. Where we introduced GraphQL was for ad hoc reporting. So one of the things I struggle with REST APIs is how to surface reports. So GraphQL seemed like a way to do that, but in practice, at least it could be the way that we've implemented it. It's not really living up to that in terms of matching the same kind of complexity we can express in SQL for generating result sets for the reports we're using for our own analytics.
How do you see APIs kind of overlapping with the use of domain-driven design? So although CQRS is orthogonal, you don't use CQRS internally, but do you see any uses of domain-driven design among your clients?
We're not getting into implementation. We're not getting to that level of either architecture or implementation with our customers right now. Like generally, they have the APIs already built. I can say that we are using DDD internally. It's probably worth a separate conversation completely, but having done DDD at startups before, there's an interesting dynamic when you're learning the domain as it's evolving, and sort of everyone is a domain expert because the organization is so small. So I've learned some interesting things doing DDD, specifically at HyperCurrent, where we were basically, I don't want to say making it up as we were going along, but the requirements were evolving as we were writing the software. And that manifested itself in terms of the domain, and then also, frankly, how some of the domain escaped into our services layer, and how we're moving that back into the domain model.
Interesting. I suppose since your product is kind of technical, it might even be more of a challenge to use domain-driven design than if, like, I guess, line of business, although you could say that HyperCurrent product is your, a line of business for you. But have you seen anything like that, maybe like in terms of working with clients in a services organization previously and how it works with an internal product?
Yeah. I mean, frankly, a lot of the organizations we were working with, there was a maturity curve just getting to APIs, or they were on the maturity curve getting to APIs. Introducing domain-driven design as part of that whole exercise, frankly, would have been a distraction, just given where they were in terms of the other challenges. But that said, we did try to influence the thinking with DDD, although not necessarily using the whole toolbox, right? So specifically like cherry picking certain patterns. So for instance, anti-corruption layer. So thinking about if there's a API that's facading a system of record, to think about those APIs specifically as ACLs that sit in front of a legacy database or a mainframe, and then transforming those into a format that matches more closely the current domain of the business. So it wasn't like we were all sitting around and having a big DDD event storming exercise, but again, sort of cherry picking the patterns and using them as best practices, from a larger perspective.
Sure, but the strategic patterns are really the most important thing anyway. So
Sure, yeah.
Any corrupting, like basically turning a mainframe data source of some kind into something that's compatible with the model of a service, it's pretty important. So yeah, good stuff.
Yep.
So if someone wants to use HyperCurrent, like if this sounds intriguing to anyone, or maybe even like where do they even start to put themselves in a position to start thinking about monetizing APIs? Like where does an organization truly become API first from the overall corporate vision standpoint? What's the next step? And then introducing HyperCurrent, how does that sort of come about?
Yeah, we have two sorts of you can call them engagement models, right? So the first kind of motion that we see is a company that already has an API, right? And they want the ability to meter, monetize, and then market it on a developer portal or an API marketplace. So that sort of motion is fairly straightforward. So if you go to hypercurrent.io, hypercurrent.io, there's a contact form. You can fill that out, and then we'll get in touch with you. For other organizations that they sort of know they need to do this but don't know how, we also have workshops that we run that goes through more on the business side what's required to stand up an API business. And then again, a lot of that is around also thinking about the business as a SaaS business versus whatever the traditional business delivery method is.
Yeah, interesting. So you mentioned a marketplace. Do you find that the marketplace is basically, individual organization based, or do you see a marketplace like AWS Marketplace as somewhere to sell APIs, or how does that work?
Yeah, I mean, for us, it's the former. So it's helping an organization stand up their own API marketplace for their own API assets.
I wonder if there is actually for the future like a kind of marketplace product where it could be industry-based, maybe segment within industry and so forth. I mean, maybe that's a hyper marketplace or something instead of HyperCurrent. Right. Yeah. Well, I'm sure you have your hands full with what you're doing now. So
not out of the realm of possibility. Well, we'll see what happens. Yeah.
Cool. Well, thanks for meeting today, John. It's Friday. I know we both had pretty big weeks here, and let me see. It's actually pretty close to starting the weekend for you. So thank you for taking time, and look forward to talking to you again. Maybe we can talk about that internal API or internal DDD kind of topic, like the ways that you work with DDD internally, and that'd probably be a pretty good future conversation.
Yeah, absolutely. I'm looking forward to it. And yeah, thanks for the time today. This was great.
Okay. Thank you for joining us today, and we look forward to getting your feedback on this podcast. So we will see you next time.